First thing is I went and looked at the last exam we took, and there was a little bit of chapter 6, not much. And then I looked over the exam, and so I removed some chapter 6. However, chapter 6 on the alkyl halides and the elimination, they come together. So there's not a lot of questions on like which solvent is the best for, well, everything that was on that the second exam, which I don't have for some reason. So there is a question on elements of unsaturation, or how many rings there are. And when we covered that, there was a question on nitrogen, and somebody told me you add 1 hydrogen for nitrogen, and I went and looked at it, looked at the slide. So on Monday's exam, there is no elements of saturation with a compound with nitrogen, but you'll probably have oxygen on there, and you might have to figure out how many rings or double bonds given the information. So here I have a compound of nitrogen, here I have a compound of nitrogen. So when I looked at the textbook's PowerPoint, they have nitrogen here, and when you put it here, you just see 1 hydrogen, except bonds 3 times. And if we look at this, say C5H11, and how are we going to figure out elements of unsaturation? Well, here's my 2N plus 2, and I get 12. What am I going to subtract from that? So when I look at this, I see that nitrogen adds 1 hydrogen. So if we subtract 1 and get 10, then we can go about life as normal. 10 from 12 is 2. Subtracting the 2, that gives me 1 element of unsaturation. And when we look at this, there is my element of unsaturation, the double bond. And the book just had 1 PowerPoint slide with a structure like this showing you that nitrogen just brings 1 hydrogen to the table. Well, let's put hydrogen on the outside. So I still have 5 carbons, 11 hydrogens, and a nitrogen. Now it's doing its thing. And we can see if nitrogen was gone, there'd be a hydrogen there, right? I put nitrogen in and it bonds 3 times and it has those 2 hydrogens. So there, we still get 11. And if I subtract 1 from 11, then I go about my usual business. I get 2, and we would see this thing having 1 element of unsaturation. So is everybody clear on how nitrogen works? You'll see it on the final, but not on Monday's exam. So other things not on Monday's exam, some of the last things we covered was the beginning of the last lecture. Right, none of this will be on the exam. I'm going to save this for exam 4, since you're going to see some of 6. So the oxidative cleavage to get 2 aldehydes. Oxidative cleavage here, you'd get 2 carboxylic acids. Here you'd get the... Alright, all this we're going to save for our 4th exam, which is the final. So it looks like there's about 7 nomenclature questions. 1 alkyl halide and about 6 different alkenes. You'll have some cycloalkenes. E and Z, where you might be required to draw the structure or given the structure.
Are there any alkynes?
No alkynes. No alkynes. So what we did first of this week, all right, moving right along. Addition reactions. So hydration of a double bond, you form an alcohol. Of course, you have something like this. This happens because of the carbocation rearrangement. All right, how about HBr with R2O2? What's that? It's a peroxide. So when you see the peroxide, you get the anti-Makartnikov. So you could get that thing there. All right, then next up, adding bromine to a double bond. Is it a syn or anti event? It's anti. And so for something like this, we want to know the outcome. I hope I got this right. I ought to because I do this a lot. So I was just going to pull up the PowerPoint slide where I said if you can't figure it out, just memorize trans gives you one, cis gives you the other. I think this one's going to be the easiest for me to rationalize because the Fisher projection, the vertical lines are going away from you. So if I think about the trans nature of this, I can put one bromine going back and the other going forward. And of course we have the back hydrogen and a forward hydrogen. And that's how I rationalize this structure. So this one here would be crazy because I'd have to spin it around. So a trans configuration is going to give you a Fisher projection with the things on the both sides. Of course, when we have a ring like that, tell me if this isn't big enough for everyone to see. That's the anti-addition. Be able to choose which alkyl halide might rearrange in an SN1 reaction. How to spell the guy. So you might have a slender base, gives you this one. You might have a bulky base, so be able to recognize the bulky base and slender base. Be able to recognize an SN2 reaction and stereo inversion. I think I just found one I didn't count the first time. There's like 8 questions that take this form. Yeah, you have about 25 through 32, so that's like 8 questions that look like this, and each one has this going on. So let's just do these 2 at least. So once again, there's a big list of 8 of these. Rate increases with concentration of the substrate. What do you think? You want to circle just one? It's all of them, yes. Because for these we have rate constant, alkyl halide. That's for those. And for these, you have the same thing, except you got the nuke thrown in. All right, all of these will increase. All right, how about the mechanism involves a carbocation? What?
Is it E2? One of them doesn't have an
Glad we're having this conversation today.
Oh, E1, right? And SN1?
Very good. All right, so I'm going to just read a bunch of these. Maybe that'll force you to watch the video if you can't write them down quick enough. But I don't want to write all of them down, but it might be things like rate increases in aprotic solvent. Rate increase, Zeta product is formed. Stereochemistry is inverted. Rate increases with better leaving group. Mechanism has 2 steps. Mechanism has 1 step. Requires antiplanar geometry.
Are you going to keep that in the video? Don't cut it out.
Yeah, maybe there's 9 names. I keep finding little nomenclature things put in everywhere. Also, there seems to be no epoxide chemistry. I don't have any epoxides. Now, round out the final. It will be chapter 9 and those leftovers. All right, so a big long list. I think I about read every one to you. So there's A through E, 5 of these. So what do you think about this first one? Looks like anti-Makarnikov hydration of a double bond. What was our super exciting reagent that had nothing boring about it? No boron stuff about it. On my card, I'd have all these reagents in the outcome, syn addition, anti-Makarnikov. What do you think would be best here? Oh, and hang on, my favorite topic, and yours as well. All right, here we see an alkyl halide, we see an alkene. We need a strong base. And we got a secondary alkyl halide, a bulky base would be fine. It might stop some other type of outcome. So like for this one here, there's only really one option, and that's some hydroxide. Now if you saw something different, let's just do this. Let me ask a question. Looks like a substitution. Should I use methanol or sodium ethoxide? Now you're given these 2 products. They look like what type of products? Looks like this and it's enantiomer, right? So we want something that has a carbocation intermediate. So we want to choose this one. Now let me just repeat this right here. This one, since it's inverted, I'm going to have to figure out SN2 and I'm going to have to get a strong nucleophile. So I'd want the methoxide. Here I'd want the weak nucleophile to make it go SN1. Yeah, so there's a few of those. Supply the reactant. This looks like an A through J. So right here, how do I want to label this? SN2, SN1, E1, E2. What's the first thing to do for all of these things? Yeah, strong or weak nucleophile. Yeah, we're going to say weak nuke. So weak nukes go SN1 and E1. Oh, and it says draw the major product. So there's the SN1 product. There's the E1 product. Draw the major product. If you draw two, circle the major one. Since this isn't very basic, I'd come up with that one there. What do you think here? Now I have a strong nuke, and I have a tertiary alkyl halide. Should I write down T-butyl alcohol? No, because these no SN2, so I'm left with E2, and I write E2. Okay, in the little time that's left, then that's the whole exam. 4 sides, 48 questions. So this is up on Moodle, and I showed it to you the other day. And familiarizing yourself with this would really help with all these types of questions. So I would study this thing and this thing, maybe put little notes of it on your card. And I handed them out to you yesterday, but I didn't have the back side. So the back side has the energy diagrams, which I think there might be one energy diagram question on the exam. Here's something that's probably a little superior to my antiquated flowchart for decision making. Predicting the products, substitution versus elimination. Is the nuke or base strong? There in chapter 6, when we looked at nucleophiles, I'd put that on my card to know which are strong, which are weak. So I can go right to this. All right, if it's strong, bimolecular. If it's not, probably unimolecular, but then we start asking these other questions. What kind of substrate? Primary, it's kind of an unfavorable reaction. 2 or 3, unimolecular. Is the base bulky? If it is, mostly E1. If it's not, mostly E2. Coming over this way, is the base bulky? Yes, E2. What kind of substrate? Tertiary, it's got to be E2. Can't do SN2. Primary, SN2. And then down at the bottom it says, under conditions that favor unimolecular reaction, weak nuke base and polyprotic solvents, mixtures are usually obtained. All right, any questions?